it's just from math. So it will be this. AL delta K minus AK delta L minus LK delta A divided by AL squared, denominator squared. Okay, now I break down this in 3 pieces, this one, and this one. Okay, 3 pieces. So 3 pieces. And the only thing that I have which is not dealt easily is big K here, big delta K, which is your step number 4 last week. Inflow of capital, outflow of capital. Okay. So if I expand this bracket, I have this. Now, look, I know everything here. So this is a little, this is y hat. Is this y hat? You got here? This is y hat. This is k hat. This is also k hat. And this is k hat. Is that right? And notice this. What is this? This is G, growth rate of technology. What is this? This is little n, growth rate of population. See, we know everything here. So, let me, and then I can, look at that. I can factor out k hat here, k hat, k hat, k hat. Okay, so if you factor out, you get solo model with technological progress with population growth rate. It's pretty similar to original solo model. Can I say here? So there are only 2 differences between original solo model and this model. What is that? What are those 2 differences? Number 1, everything is in terms of hat. K hat. Everything per effective worker capital. That is number 1. So everything in this model, everything is in terms of effective worker. Okay. Number 2, you remember G? Technological progress, it shows up here. Look at that. Remember, I started from delta. I added population plus n, added technology plus G. Okay, he defined his production function like that to get this nice relationship very similar to original model. Original model, be careful, is not exactly original model. It's y hat versus k hat. Everything per effective worker output. Per effective worker output and capital. Okay, so now this part, f of k hat. F of k hat looks the same. Remember, your technology still has constant return to scale, diminishing return to capital. So it has very concave shape as before. So, but only hat. But shape is the same. Okay. So S, f of k hat, the same. So depreciation line is kind of steeper because delta plus n plus g. Okay. So steady state equilibrium, the same idea. Inflow of capital, outflow of capital, effective worker everything. Okay. So steady state equilibrium, but in terms of hat, k hat, y hat, k hat, y hat. Okay, that's it. That is that. Now you have to be very careful. This model is kind of confusing. It's kind of misleading. Okay, so here you have continuous technological progress without having a shift. See, this is called solo model with embedded technological progress. Technology is getting better G% per year without shift. Remember? Because shift, continuous shift, messes up our graphs. Okay, we don't want that. So Mr. Solo came up with this three, having continuous technological progress without having a shift. But again, it's okay. As you will see, you have to be careful how to interpret that. Okay. One more thing that you have to remember is, as I said, it looks silent, but underlying variables are moving a lot, okay? Let me give you an example. Okay, guys, suppose my economy is in steady state equilibrium point O. Is that right? My first question is this. My first question is, what is the steady state equilibrium of, actually let me focus on y hat. Suppose I am at point O, what is growth rate of y hat? This must be easy. Growth rate of y hat when I am at point O, steady state equilibrium, so y hat, y hat is what? Y hat is fixed, so its growth rate is 0. Is that right? So, see? So, output and per effective worker capital fixed. So, growth rate of per worker output, per worker capital, just 0. Is that right? Okay, by definition. Now, this is very interesting. I said we have three things. Per effective worker output. How about this one? What is the growth rate of per worker output? Anyone? We are at point O. What is growth rate of little y? Per worker output. So you have to be very careful here. Anyone? So you should know relationship among these variables. Big Y, little y hat. Okay? Anyone? Any suggestion? So if economy is at point O, per worker, per labor output is growing at what rate? Yeah? No. You see, it would be G. It would be G. Why? This is the relationship between y hat and y is y over a. So you see, y hat is fixed. Y hat is fixed. Its growth rate is 0. This is fixed. But remember, we know that A is going up at the rate G. Is that right? So, you see, you have a ratio. Denominator is growing G. Total ratio is fixed. So what is the growth rate of numerator? Growth rate of numerator must be G. Is that right? You see, if you have a fraction, the fraction is fixed. Numerator is going up at rate G. How can denominator goes up at rate G, but the whole ratio is fixed? There is only one way. Numerator must go up at rate G. Okay, so per worker output and per worker capital are growing at rate G. So actually you can think about that this way. You see? So remember, per worker output is equal to A times per effective worker output. Okay, remember, if you cross product that ratio, you see, this is fixed. This is fixed. Steady state equilibrium. So A is growing at rate G, so Y has to grow at rate G. Okay. My third question. What is growth rate of total GDP? Total output. Anyone? Total output. what? N plus G. N plus G. Why N plus G? Because of this. You see, you remember total output. Total output is equal to total output would be L A L Y hat. Remember? This is per effective work per output. If I want total output, I have to multiply it by effective labor. So A L Y hat. Growth rate of Y hat is 0. Growth rate of L is N. Growth rate of A is G. So you remember, guys, we talked about this algebra of growth rate. So if 3 variables are multiplying and each of them has its own growth, multiplication is growing at what rate? So make sure you know how to deal with growth rates. This is something that in economics, when you work in future, you need to know them, okay? So, you see, if you have a bunch of variables, each of them has its own growth rate. So multiplication would have a growth rate, by the way, this is approximation. Approximately the sum of growth rates. Sum of growth rates. You remember algebra, we talked about this. Take logarithm, differentiate. So growth rate of y would be growth rate of a plus growth rate of L plus growth rate of y hat. Growth rate of y hat is 0, growth rate of L is N, growth rate of A is G. Okay, so N plus G. Okay, another thing, guys, I have 3 things. I have total GDP, I have per capita GDP, or per labor GDP, and I have per effective worker GDP. From welfare point of view, which one is more important? If you want to investigate welfare of an economy, so do you look at total GDP, per worker GDP, or per effective worker GDP? Which one do you, from welfare point of view, which one matters? Any suggestion? No suggestion? So what people do in real life? The middle one is important. Per worker. Per worker is per worker shows my share of GDP. Is that right? You never look at total GDP because a country could, for example, you remember last week I compared China with Denmark. Denmark is a little. Can you see that? So from total GDP, obviously large countries have large GDP. But from welfare point of view, this is important. So as you can see, you remember Mr. Solo discovered what? Mr. Solo discovered that continuous growth rate of GDP is coming from what? Per capita GDP. It's coming from where? You remember technology. Technology is engine of growth. Look at that. So in very long run, growth rate of an economy is depending on the rate of technological progress, G, nothing else. So you remember from welfare point of view, G is important. If G goes up, people are better off. So from welfare point of view, per capita variables, per worker variables, per labor variables. Okay, let's do a little bit exercise. So suppose G goes up. What happens? That's why I told you this model is a little bit confusing. Remember, I said welfare is depending on G. Okay, remember growth rate of per worker output. If G goes up, obviously people are better off. Okay? But can you see that this model, see, G goes up, so depreciation line shifts. What happens is, you see here, this is counterintuitive. Because remember, we just said that if G goes up, welfare goes up faster. You know that? But this graph is kind of counterintuitive because it looks like y hat is going down, k hat is going down. Did you see that? So are really people better off? So, but I told you, y hat doesn't matter, y matters. Okay? See here? See here? So, see, y hat is a times y hat. Y is equal to a times y hat. Okay? This is important, not this one. Of course, the graph shows this one goes down. But don't forget that. A is growing faster. A is growing faster. So A goes up, remember? Y goes down. Of course, from pure algebraic point of view, multiplication is ambiguous. But I am going to, from economic point of view, we know that multiplication, this is dominating this one. How do I know? Remember? I said when technology is progressing, production function shifts up, new steady state equilibrium is, remember, northeast. Northeast means what? Northeast means if you have technological progress, northeast means capital goes up, output goes up. That is it? So it means you cannot have technological progress and this is going down. It's impossible. Therefore, this one is dominating this one. Okay? So as I said, the model is confusing. In fact, the next exercise model would be more confusing. So from timeline, you can see why people are better off. So you remember beginning of chapter 8? We talked about algebra of growth. So output is growing at G. Remember that? The worker output. I told you, don't draw output over time. Draw logarithm of output. We talked about it last week. Okay? So why? Because then the slope shows growth rate. See, initially, growth rate of technology was G. So economy was moving along this path. But when growth rate of technology becomes G prime, that is it, economy is moving to faster track progress. Can you see here? So fast track, can you see that? So as you can see here, people are definitely better off at any point in time. You see, after this, when G becomes larger and economy is growing faster, so as you can see, any point in time, so people would be better than slow track, fast track and slow track. So I am telling you this because of this. What happens if n goes up? What happens if n goes up? But you see, from graph point of view, it looks the same. See, n goes up, g goes up. So we have rotation. So did you see that? It looks like per effective worker variables are going down. I am asking the same question. Are people better off or worse off? Your graph is exactly like the previous one. But in this example, people are worse off. that's why I'm saying this model is, you have to be careful, okay? Because the concept of, you have to grasp the concept of per effective worker variables. You see here, here, see, why people are worse off, you see here? From the graph, you can see that white hat is going down. But don't forget that, as opposed to previous case, growth rate of A remains G. This doesn't change. So as you can see, people are worse off. Again, graph shows only this part. But from welfare point of view, this is important. That is, see here, economy is always growing at rate G, technological progress. In this case, before shock, after shock. However, here, after shock, you see, the economy speed remains the same. Okay, but because white hat is going down, as you can see, economy goes, output per capita goes down at any point of time. You see that? So people are worse off at any point in time. You see that? So again, from graph point of view, graph shows only this part. But from welfare point of view, we are interested in little y. So you have to be careful how you interpret that. Okay, but of course, Mr. Solo proved technology is the force behind the growth. But unfortunately, Mr. Solo didn't go out of the wood because there were economists still criticizing him. Remember the problem here? The problem that economists criticized Mr. Solo was this one. Remember? Mr. Solo said why economies are growing continuously. He said what? Technological progress, yes? But look at that. He assumed that technology gets better at rate G. So some economists didn't like that. Some people said this is kind of cheating. Can you see that? Because they believe that, because they said, okay, they asked Mr. Solo, okay, technological progress is behind continuous continuous growth of economy. Is that right? But the question here is, why technology is getting better and better? What technological progress? What produces technological progress? So there is that. This model doesn't have any answer for that because Mr. Solo just assumed that. So that's why his model, yeah, he got Nobel Prize in economics, but still criticism, okay? So that brings me, if you take a course in growth theory today, they are talking about a new kind of models these days, you see? So now we have two kinds of models. Exogenous growth models. In exogenous growth models are models that follow Solo. So they assume that technology gets better at rate G from outside. God knows where G comes from, okay? But as I said, some economists, they said no. So they went after creating endogenous growth models. Endogenous growth models, they say technological progress must be created within the model. You cannot just simply assume it. Okay, can you see it? Endogenous, exogenous. Okay, of course this is hard. So the most famous economist criticizing Solo was Romer. Romer himself created the most famous endogenous growth model, and he won Nobel Prize 5 years ago. 5, 6, 7 years ago. Just recently. Okay? So, so for the hard part about endogenous growth model is of course, you need to come up with the story. You need to come up with the story why economy, why technology gets better at continuously from within. So you need to take a course for endogenous growth models. But what I can offer you here is something called AK model. This AK model is not a growth model. This is the engine of all endogenous growth models. If you can come up with the story, endogenous growth model is so important they put your name on it. Because you should have your own story. Like Rover model, like Barrow model. Robert Barrow, my professor, he came up with his own story. Now we call it Robert Barrow model, okay? So, but AK model is the engine of all these growth models, okay? Why we call this AK model? Because it's working in the framework of Solo model, but its production function is A times K. YT is A times K. So A is nothing, by the way. It's just a fixed number. It's not representing anything. Okay? It's a fixed number. Now your story, why production function is like this, that is depending on the story that you have to come up with. Okay? But after that, if you come up with the story showing that your production function is A times K, then the rest is easy. Why? Okay, so let's do this under framework of Solo model. I told you, whenever you get a production function, make it per capita, per labor, okay? So this is per labor, production function, and just plug everything that you have into production function, into your Solo equation. So let me plug this here. Okay, so I get this. And then I told you to draw the graph. Look at that. You see here? Here, production function is not concave anymore. It's linear. It's a line. It's a line, this part, AK. And then I have SAK. SAK, remember, investment function, investment term. And suppose, remember that is depreciation line. Suppose it falls below those two. Okay? Okay, guys, you tell me. There is steady state equilibrium for AK model. There is steady state equilibrium for AK model. Anyone? We talked about this last week. So the only steady state equilibrium that this model has is what? The origin, you remember that? By the way, it's boring. I mean, and no economy in the world is there. Okay? So suppose your economy is here. If your economy is here, what happens? Your economy is growing forever. Why? You see, because, you see, inflow of capital is more than outflow of capital. Inflow minus outflow. So it means economy is growing forever. But I can measure its growth rate. Economy is growing forever. At what growth rate? Okay. At what growth rate? Let me divide both sides by K. KT, KT, KT. So KT goes away, KT goes away. So I have this. See? Growth rate of capital is equal to SA minus N plus delta. You see that? So, continuous growth. Now, as I said, the only thing here is why your production function is like that. You need to have a good story. If you have a good story to make your production function like that, they put your name on that model. So few people in the past they did. Okay, like a Rover model, Barrow model. Okay, so but as soon as you get AK model, The remaining is easy. Don't forget that growth rate of economy in this model is a fixed number. It's a fixed number, okay? So, by the way, per worker output, per worker capital, they grow at the same rate. For example, suppose you have a poor country and you have a rich country, you see? By poor country, I mean the poor country is here, rich country is here. So, K rich country, K poor country. Can you see it here? So what happens? If you have a poor country and a rich country with S, A, and delta numbers, yes? So these two countries are growing at what? If you plot the numbers over there, so these two countries are growing at 2% per year. Now, you tell me, do these countries converge to each other? So rich, poor. So both of them are growing 2% per year. Do they? You see? Both of them are growing at the same rate, but one of them is richer. So a rich country remains rich. Is that right? So you see, no convergence. I mean, so poor country cannot get to rich country. How about this? So you see, you have a poor country. So saving rate A and delta. So poor country is growing at 3% per year. And suppose information for rich country is like this. So rich country is growing at 1% per year. So now what happens? Poor country is behind, but it's growing faster, 3%. Rich country is ahead, but it's growing at 1%. What happens here? Do we have convergence or something? You see? See here? Poor country is going to catch up. Rich country and becomes richer and remains richer. You see that? This process of catching up is called leapfrogging. So a country comes from behind, catches up, goes ahead. Okay. And finally, what Mr. Solo did, he contributed a lot. For example, another interesting that he did was this. So you remember we talked about technological progress. But you may ask yourself, how do we measure technological progress? Yeah? Because things are getting better. I mean, phones are better, computers faster. So you have AI now. So how do we measure technological progress? So he was, again, the first person coming up with a plan. Of course, people criticized him a lot. When you are inventing something new, people are, so yeah, he has some problems. So, you see, he measured technological progress using a technique called Solo residual. So, you see, there is something called growth accounting. Growth accounting says what? Growth accounting finds the sources of economic growth. An economy is growing for 3 reasons. More capital, more labor and resources, and better technology. Yeah? I mean, they are representing sources of growth. Okay? So let me use a simple calculus production function and let me represent technology using, you remember chapter 3? We call that total factor productivity. We put technology outside. Okay? So let me define it this way. This is what he did for Solo residual. So you know what to do. We talked about this. Take logarithm of both sides, differentiate both sides. So it becomes what? Growth rate of output is growth rate of technology, alpha growth rate of capital, growth rate of labor. Okay? So you see here, growth rate of output, growth rate of technology, growth rate of capital, growth rate of labor force. Okay? And alpha is depending on your economy. Remember, if you estimate a capitalist production function for your economy, alpha shows the share of capital, impact of capital on your output. Okay, so you can estimate that for any country. So now look at here. Look at this relation. Look at this relation. Suppose I know alpha, I estimate for my economy. You see, we can measure growth rate of capital because capital is observable. We have growth rate of population. So we have growth rate of output. So what is unknown here? Growth rate of technological progress. You see? So technological progress is, so he said, if there is a part of growth rate of output that cannot be explained, that is explained by what? Technological progress. There is a leftover. So that's why it's called solar residual. Solar residual. You understand? Because the rest are observable. You can measure everything else. So the part of growth in output which cannot be explained by better more people, more capital should be assigned to technology. Understand? So you know my favorite production function. So alpha, you have to estimate alpha for your country, and then leftover residual growth rate, it can be explained by technology. This is an approach that was offered by him. Okay, so for example here you can see estimations. You see, for many countries. So you see, they found this total factor productivity. This is a growth rate of technology. For these countries, you have growth rate of output, growth rate of capital, growth rate of labor, and also the estimated capital gross production function for these countries. So alpha. So they found what? The contribution of technology, or so-called total factor productivity. You understand? So he for first time invented that. Okay, that was I wanted to make sure that we cover very long run. Okay, so that is the model. MGEB model, solo model, different versions of solo model. Okay. So let me go back and, as far as we have time, cover open economies in short run. Remember, that is a chapter that we jumped. Okay, so we went from 12 to 8. So 12 and 13. So open economies. We talked about open economies in short run. Remember chapter 6. Okay. So, but what's going on in short run? What's going on in short run? Okay, so here, remember in chapter 6, I defined two things which are very crucial for this chapter. So, concept of a nominal exchange rate, concept of real exchange rate. Remember, please review those. They are tricky concepts that you have to remember. Okay. Now, you remember chapter 11 and 12. Chapter 11, I wrote down a model for goods market in short run. Remember, Keynesian cross, and then we found IS curve. So now we have the same thing for goods market, IS curve. The only thing here is I have extra term, output, consumption, investment, government spending. So in closed economy, this part was missing. Now it's there. now it's there. Okay? So, but don't forget that. That was for closed economies. For open, remember, my country is small open country. So small open country means I don't have independent interest rate. My interest rate is stuck to foreign interest rate. That's the meaning of small open economy. So as you can see, my investment is stuck to foreign variable. And also, you remember in chapter 6, I said net export is a function of, you remember real exchange rate, remember that? We talked about real exchange rate. And real exchange rate relation was this, you remember chapter 6? Now, we are in short run. So short run means what? Short run means these two prices are fixed. You remember that? Short run prices are fixed. So if short run prices are fixed, so it means what? Real exchange rate, you see, this is something that we didn't have in long run. In short run, real exchange rate and nominal exchange rate move together. You see that? It's a very big difference between short run and long run. Because prices are fixed in short run, nominal and real exchange rates move together. So that's why I allowed myself, instead of this, write that. You see that? Instead of, so you know that real exchange rate is like net export is a function of real exchange rate. Remember, price ratio between two goods, not currencies. Okay? So, but in short run, we can do that. Okay? So, this is very interesting. This is very interesting. By the way, I call this IS star, not IS. This is goods market in open economies. To remind you, it's open, remember star. There is another difference too. Remember in IS curve in open economy, IS curve in closed economy, here I had Y, here I had real interest rate. You remember that? Remember IS? But here, this picture is useless. Because real interest rate is stuck to foreign interest rate. It's a fixed number. To draw a curve against possibly a fixed number is just useless. Because it doesn't, on a star is exogenous. Okay? So, however, now important variable is nominal exchange rate. You see that? So I star is a function, a relationship between output and nominal interest rate. Okay? That's another reason we call that IS star. IS star. However, I drew it downward sloping. How do I know it was downward sloping? So let's see. So let's explain that. So IS is downward sloping. Suppose E goes up or down, it doesn't matter. So suppose E goes up. But remember, this is short run. If E goes up, it means epsilon goes up. Real nominal interest exchange rates are moving in the same direction in the short run. Okay? So it means what? It means real exchange rate rises. But can you remind me, higher real exchange rate, you know, we call that appreciation. Okay? Higher real exchange rate means what? Domestic goods are what? Anybody? Can you remind me? If real exchange rate goes up, domestic goods become? Anybody? This is the part that you have to practice, it's confusing. So if epsilon goes up, we call that real appreciation. It means domestic goods are more expensive. Foreign goods are cheaper. Remember that? So domestic goods are more expensive, foreign goods are cheaper. Okay? So that means export falls, import rises. Is that right? Yes.
So what's the shock?
There is no shock. Here I am trying to prove that IS star is downward sloping. So shock would be next. I am constructing my curves. I just you may ask me, how do you know IS star is downward sloping? good luck also. So I say, suppose it goes up, E goes up, okay? When E goes up, so you remember in short run, nominal appreciation means real appreciation. Real appreciation means eventually net export going down. Net, but look, this is for foreign. Listen, this is open economy. Net export is part of planned expenditure. You remember that? C plus I plus G plus net export. So net export is part of planned expenditure. So planned expenditure falls. So inventories rise. So, and then remember, it takes time until finally output falls, income falls. So did you see that? Negative correlation. E goes up, output falls. So here I am just constructing my goods market equilibrium. Don't forget that this is representing all possible equilibrium points in goods market. Is that right? In goods market. How about this? Money market. Remember? Money market. This was what? This was demand for money, real money. This was supply of real money. You remember that? The same thing. The same thing. So LM star. Okay. Why LM star? Because now R is not involved anymore. R star is involved. Case number one. Case number two, the difference is we are drawing an M curve not in the space of R and Y, in the space of exchange rate and Y. Exchange rate and Y. Okay, but can you see that here? Here in LM curve, in money market, basically exchange rate doesn't play any role. It doesn't exist. Okay? And also, did you see that? So M is fixed. Okay? Suppose central bank doesn't do anything. This is short run. You remember short run price is fixed. And also you remember this one? Important one. Interest rate is exogenous. So too many fixed things. How can I have equilibrium in money market? So for given M, given P, given R star, there is only one possible income level that can bring financial money market to equilibrium. Can you see it here? So as you can see, by the way, as I said, there is no exchange rate over there. So it's vertical. This is just vertical. Okay. I am sure you can guess what happens next. I put together what? IS, LM, and I find equilibrium everywhere. Okay, so let's just do that. Can you see that? So IS, LM, IS star, LM star, but I have to say star. Equilibrium in intersection is representing what? Equilibrium in goods and money market at the same time. So now, actually, did you see that? The role of nominal exchange rate in short run is very important. Why? Because of this. In short run, nominal exchange rate plays the role of this. So real nominal exchange rate is changing. Nominal exchange rate changing, make sure goods market and money market are in equilibrium in short run. Can you see it here? That is the job of nominal interest rate in the short run. Nominal, not nominal interest rate, nominal exchange rate. The job of nominal exchange rate in short run is make sure goods market and money market are in equilibrium. You see that? Okay. That's the model. That's the short-run model in open economies. So now let's talk about what she asked. Okay, so this is my model. So you can use what? You can use any kind of charge policy, all right, from here, because now you have constructed all your curves and you can apply all policies sharp set you want. For example, suppose G goes up. Anyone? So you have experience of G and IS curve. That's all right. So the same experience as IS star curve. What happens? Anyone? G goes up. What happens? Your final exam now. Part 1. Graph. So you remember IS always higher G shifts IS to the right. You remember that? Okay. Because G is what? Government demand. So at any exchange rate, government demand would increase total demand. Total demand. So what happens is, now this is very interesting. Please make sure, guys, please make sure you go home, study open economy next to closed economy. So chapter 13 next to chapter 11 and 12. Okay? So remember, increase in G in short run, closed economy increased by. You know that? But not in open economy. In open economy, overall output remains the same. Why? Appreciation, it leads to appreciation, and net export. Net export falls and make that up. Make increase in GR, okay? So yes. Yes. Oh, did you? Oh, I thought you have a question. Okay, so G goes up. By the way, you know majority of these are. So planned expenditure rises. So okay, output rises, but I wrote tends to rise because at the end you will see it will be offset by something else. So output tends to rise. So by number, people need more money. When income goes up, demand for money goes up. So when demand for money goes up, people start selling bonds. Bonds become cheaper. That means, look at here. Remember, this is open economy. Domestic interest rate cannot go above foreign interest rates. But can you say there is a pressure? There is a pressure for domestic interest rate going above foreign interest rate. So that causes capital inflow. Capital inflow. So capital inflow is triggered. But capital inflow means what? It means foreigners are trying to buy domestic assets. Remember, domestic goods. So demand for domestic currency goes up. The demand for domestic assets, domestic currency goes up. So domestic currency becomes stronger, nominal appreciation. So nominal appreciation. So nominal appreciation in short run means real appreciation. Careful, this is true only in short run. Because price is fixed, real and nominal exchange rates move together. But when, we are going to talk about that at the end of this chapter. When price is flexible, epsilon and E can move differently, okay? Okay. But this means what? Real appreciation means export falls, import rises, net export falls. So you see, so here G tends to increase planned expenditure. Here net export reduces planned expenditure. So overall income remains So overall income remains fixed. You see, these two cancel each out. These two cancel each out. Overall output remains fixed. Net export cancels out G. So consumption would be the same, investment would be the same. Catch it here? So that's a major difference between open and closed. Yes?
How we can tell if something factor demand will change or that graph will change? Like what each effect? For example,
You see, we talked about this. Change in output is not fast. That's why you have inventories. You know that? You know what we talked about? You know Keynesian cross? Keynesian cross means what? If demand goes up, output cannot go up. So you have inventories. That's why change in goods market, that's why you have inventories. What's the philosophy behind inventories? You were chapter 2, we talked about that. Chapter 2, we have inventories because supply and demand may not match because supply is output. Output is moving slowly. Okay, but in money market, you have supply of money, you have demand, you have supply of real money, demand for real money. Do we have any inventory in money market? No. So it's not possible that I am walking along the street and I see a whole lot of money on the street, on the floor, okay, and I say, what is that money? Everybody said, oh, that is excess supply of money. in money market, everything is fast. Supply and demand always match. It's impossible you have, so that's why there is no inventory. But basically, the reason, the philosophy behind inventory is just that. Because demand for goods and supply of goods may not match. So inventories are used in order to match this. Now, please read closed economies, increase in G, okay? So, in closed economies, G goes up, output goes up in short run. Not here, okay? So why? Because of this, you get here? Because you have a short run, P is fixed. Is that right? P is fixed. Suppose central bank doesn't do anything. M is fixed. Interest rate fixed. So as you can see, what is variable over there? So it means income, output cannot be, income cannot be different. Do you see that? So output is fixed, income is fixed, then output, income fixed, so this is fixed. Suppose we don't touch taxes, so consumption would be fixed. Investment is fixed because investment is a function of foreign interest rate, fixed. So what is left here? So here we have these two. Is that right? G goes up, net export goes down. G goes up, net export goes down. So they cancel each out. So be careful. In small open economies, fiscal policies are ineffective. Fiscal policies are ineffective, impacting output. One more thing, please go and double check with chapters 11 and 12. In closed economies, G goes up, investment goes down. You know, we call that crowding out effect. Crowding out effect. In closed economies, then you have expansion in fiscal policies. Remember, interest rate goes up. When interest goes up, investment goes down. So in closed economies, expansionary fiscal policies crowd out investment. But in open economies, investment is fixed. You remember that? It cannot be crowded out. So in small open economies, of course, so fiscal policy, expansionary fiscal policies crowd out net export. Crowd out net export through what? Through exchange rate. Exchange rate. First one, is happening by affecting interest rate. Please double check chapter 11 and 12. Major difference between. Let's do one more exercise. Expansionary monetary policy. Expansionary monetary policy. Okay, guys, can you tell me what happens from a graphical point of view? You have an M curve. An M curve, you see here? You see? This is fixed. This is fixed. If M goes up, Y has to go up. Can you see that? So that causes, in fact, in open economies, monetary policies are very effective. You see that? Monetary policies are very effective. Increase output. But how? By depreciation. Depreciation and increase in net export. Depreciation and net export. So let me write everything here. So you know that central bank buys bonds. Bonds become more expensive. So you see, domestic interest rate tends to go below foreign interest rate. But don't forget that, it doesn't go. Yet it's just pressure to go down. Okay? Pressure. But how does that pressure go away? So there will be capital outflow. Because domestic rate of return tends to be lower. It tends. It doesn't happen. Okay? So capital outflow. Capital outflow means demand. Okay, see here? So demand for foreign currency, foreign assets goes up. You see that? Because people want to go out. People want more foreign currency, foreign assets. Okay? So nominal depreciation. Nominal depreciation. It means weaker domestic currency. Weaker domestic currency. But remember, in short run, prices are fixed. Nominal depreciation means real depreciation. Real depreciation means net export is improving. More export, less import, is that right? Because depreciation is what? Domestic goods become cheaper. So export is easier. Foreign goods are more expensive. So net export goes up. Planned expenditure goes up. Inventories, then going back to her comment about, you see, change in output is not fast. Change in output, you see, I always put this here, inventories. You see, changing in demand is not enough to change in supply. It goes through inventories. But in money market, there is no inventory for money, okay? So output rises, consumption rises. So investment is still the same. Investment is still the same. Oh, sorry. Investment is the same. Can you see that? In small open economies, monetary policies are effective. Fiscal policies are not effective. All right? So, you see, monetary policies, exactly like fiscal policies, are affecting output in a different way. In closed economy, remember, monetary policies, M goes up, they led to lower interest rate. Please double check chapter 11 and 12. So investment went up, output went up. So this is called investment channel. But in open economies, M goes up, depreciation, nominal depreciation, real depreciation, net export goes up, output goes up. Can you see that? In open economies, monetary policies are working through trade channel. But in closed economies, monetary policies work through investment channel. In open economies, money supply is affecting nominal exchange rate. In closed economies, money supply is affecting real interest rate. Okay? So, monetary policy, be careful. Total demand, world demand doesn't change. So as you can see here, only is monetary policies of country shifts demand for foreign goods to demand for domestic goods. Okay, it's just reshaping. So more likely, more output, more employment in this economy would be at the expense of total economy, total output and employment abroad. Okay, actually there are more exercises, but let me leave that for the next week. Okay, so there are more exercises before I switch to a new model. I mean, more complete model. Okay, so make sure practice. So be ready for the